You are most welcome, my dear viewers, to this presentation, and a wonderful one. In this presentation, we are going to talk of solving equations with unknown indices. And this is our third presentation about indices. So if you have not yet watched the other two tutorials about indices, where we have the introduction to indices and then the rules or laws of indices, please, the link of the playlist is just below the description. You can go there and tap on them so that you can watch them for better understanding. And if you are new to this channel, please support the channel by kindly subscribing and hitting the notification button so that you are notified whenever I upload a new video. Like and share. So let's now dive into the video. We have number 1 up to number 6. I'm going to take you through one by one. That means you are going to be solving for the values of x and y, whatever it is or wherever they are in these equations. Let us begin with number 1. Number 1, it is 2x equals to 8. We can use two methods. Let's have method 1. By following the rules of indices, this implies that we have 2 power x is equal to, if we break down these terms of 2, the same as having 2 to power 3. And we are saying that by comparison, since the bases are the same, let's compare the powers. It implies that our value of x equals to 3. This is what I'm meaning. X equals to 3 as the base are the same, meaning that the value of x is 3. We can have method 2 as we have 2 to power x equaling to 8. What we are going to do, we are going to introduce logarithm to base 10 on both sides. So as we introduce logarithm of base 10, so we are having 2 log of 2 power x equals to log of 8. You have the rule of logarithm that if you have log of maybe a to power x, this one comes this side and we shall have the same as x log of 8. So it's what we are going to do here. It's going to drop this side so that we have x log of 2 equaling to log of 8. Now we make x the subject by dividing through by log of 2 on both sides. So divide through by log of 2, divide by log of 2. So we have x equaling to log of 8 divided by log of 2. As you press a calculator, I see that mine here is giving me the value as 3, which is our answer. It corresponds to the one we got there. We can now go to number 2. Number 2, we have 3 power y equaling to 7. So this one, since the bases are not the same, we are going to go through method 2, not method 1. Here method 1 doesn't work. It's only method 2 that will work out for us. So we are going to introduce logarithm of base 10 on both sides, which means we are going to have log 3 power y equaling to the log of 7. Just know the base of the logarithm is base 10, because any log without a base automatically is in base 10. As we simplify this, we are having this y coming in this side. So we have y logarithm of 3 being equal to log of 7. To make y the subject, we are going to divide through by log of 3 on both sides of the equation. So divide through log of 3, divide by log of 3, meaning that y is equal to the log of 7 divided by log of 3. If I press the calculator, can also press the calculator, it gives the answer as the value of y 1.77124374916. It's a non-terminating decimal, so you can say that y is equal to 1.7712. It is correct to 4 dp, implying that this is our value of y. We can have number 3, which is 2 to power 2x plus 1 minus 7 multiplied by 2 to power x plus 6 equals to 0. So what we are going to do, we are going to express this term, the first term, this one, in terms of this, so that we have something common throughout as having the unknown, which is x. So this implies that our first step, this is by considering the rules of logarithm. This is the same as having 2 raised power 2x. Since it's addition, then it was a multiplication into the 2 power 1 minus 7 multiplied by 2 power x plus 6 equals to 0. This is the same as having 2. As we break down this again, so we are having into 2 raised to power x, but again power 2. Because this is 2x, I want to have a 2 power x. So now minus 7 into 2 raised power x plus 6 equals to 0. From here we can see that we have the common here, which is 2 raised power x. We can say that let 2m be the 2 power x. As we substitute in, we are going to have the 2m but squared minus 7m plus 6 equals to 0. This is a quadratic equation which we can solve by methods of solving quadratic equation. If you have not yet watched these videos, please, the link is in the description below. You can watch completing square method, factorization method, using a quadratic formula, and then a graphical method. But in here, for this case, we are going to use factorization method because I can see it is factorizable, whereby the sum of the factors should be -7, and then the product of factors should be 12, as multiply 2 multiplied by 6 to give us 12. So in here, the factors we are going to use -3 and -4, meaning that if we multiply them, multiply -3 multiplied by -4, we shall get a positive 12, which is the product of the factors. This is a product. And then if we are now to sum them, -3 plus -4, we shall get -7, which is the sum of the factors we have. So it is factorizable. Our next step should be now 2m squared. Now instead of having -7m, we substitute these factors with their corresponding signs. So minus 3m minus 4m. The criteria is that here should give us the -7m, so that we don't change the meaning of the equation. Plus 6 giving us 0. So the common here is our m, we put it out, into shall remain with the 2m, minus here we shall have remained with 3, close the brackets. The common here is the 2, so we put out the -2, into here we shall have remained with the 2m, minus, you having 6 divided by -2, we get -3 equal to 0. Continue factorizing out. What's common is 2m minus 3. We put it out into, here we shall have remained with the m minus 2, giving us 0. So either 2m minus 3 equals to 0, implying that we having 2m minus 3 plus 3 equals to 0 plus 3. This one cancels. We have 2m equals to 3. We divide 0 by 2 on both sides, implying that our m is equal to 3 divided by 2. That is the either part. Then or m minus 2 equals to 0, implying that our m minus 2 plus 2 equaling to 0 plus 2. Implying that m equals to, these two cancels, 2. So we are having two values of m. We have the 3 divided by 2 and then 2. But we say that m equals to the 2 raised to power x. And now for m equals to 2, it implies that we have 2 power x being equal to our m, which is now 2. And now this 2 is the same as 2 power 1. So by comparison, since the bases are the same, it implies that our value of x is 1. Since the bases are the same, therefore we have our x equaling to 1. Or for m equaling to 3 out of 2, it's going to imply that we are having the 2 power x being equal to 3 divided by 2. So this one we can solve by introducing logarithm of base 10 on both sides. So this implies that we are going to have log of 2 power x equaling to log of 3 out of 2. Rules of logarithm, this one is going to be dropped to that side, so that we can have the x multiplied by log of 2 being equal to log of 3 divided by 2. To make x the subject, we are going to divide it through by the log of 2 on both sides. So we divide it through by log of 2 divided by log of 2, so that we have x being equal to the log of 3 divided by 2 divided by log of 2. When we press the calculator, our value of x is coming to be 0.5850, and it is correct for dp. Therefore, the values of the power, and the power is x, 1 and 0.5850. Said correct for dp. We can have number 4, which is the 3 raised to power 2x plus 1 plus 3 equals to 10 multiplied by 3 raised to power x. That means we are going to break down this first one in terms of x raised to power, 3 raised to power x. So this implies that our response is going to begin by having the 3 raised to power 2x into, this is addition. It means that the bases were the same. Then we have 3 power 1, then plus 3 equals to 10 multiplied by 3 raised to power x. This is the same as having the 3 raised to power x, but still power 2 multiplied by 3 plus 3 equals to 10 multiplied by 3 raised to power x. So this is the same as having the 3 into 3 raised to power x but squared plus 3 equals to 10 multiplied by 3 raised to power x. We can now begin by let maybe p be the 3 raised to power x. Now as we substitute in, you're going to have the 3p but squared because of these 2 plus 3 equals to 10p. So let's now form a quadratic equation by taking this one the other side, this one this side of the equation. So we are having 3p squared minus 10p plus 3 equals to 10p minus 10p. This implies that we have 3p squared minus 10p plus 3 equals to 0. So this one is also solved by factorization methods. So we are using factorization methods. So the factors are -1 and -9 because the sum of the factors is 10, -10. If we add this -1 and -9, we get -10. Then as we multiply the 3 times 3 is 9, and see we multiply -1 and -9, we get 9. So these are the correct factors. It means that we are going to have the 3p squared minus p minus 9p plus 3 equals to 0. Let's factorize out. P is common, we pull it out. Shall remain with the 3p minus 1. Then we pull out the -3 which is common. Here we shall be remaining with 3p minus 1 equals to 0. 3p minus 1 is common, we pull it out. So we have 3p minus 1 into, so it remains with p minus 3 equals to 0. Either 3p minus 1 equals to 0, implying that we have 3p minus 1 plus 1 which is equal to 0 plus 1. So 3p equals to 1. So if we divide through by 3, we are having our p being equal to 1 out of 3. Or p minus 3 equals to 0, implying that our p equals to a positive 3. So these are the two values we are getting. Then we proceed. Since we said that our 3 raised to power x is equal to p, now we are saying that for p equaling to 3, it implies that we are having the 3 raised to power x equaling to 3 is same as power 1. And so by comparison, it means that our x is 1 since the bases are the same. For this case, x equals to 1. Then remember I got two values of p. For p equals to 1 out of 3, it implies that still we have 3 raised to power x being equal to 1 out of 3. And the rules of indices we talked about. If you have not yet watched, please, the link is in the description below. We say that this is the same as having the 3 raised to power x, which is the same as 3 raised to power -1. And so we can see the bases are the same, the bases are the same. So we can just compare the powers or the exponents. It implies that our value of x is also equal to -1. Therefore, the values of x are -1 and 1. And please try out these other numbers. Try out numbers 5 and number 6 and drop the answers in the comment section so that I can get to know where we have so far reached. And please, you can watch also this video about sets. Thanks for watching. See you again.